Hey guys, welcome back. This is Congruency Part 2. Um, Hopefully you didn't get too overwhelmed with all the markings on the Part 1 of the Congruency video, but this one should be pretty quick. We should be able to zip through pretty quickly. So let's see what we have in store. So first of all, a couple of the main vocabulary words we want to talk about and keep in mind as we are talking about congruency. And first of all, the first word being congruent, and there's our symbol. Looks like an equal sign with a little wavy line on top. It's the same shape, same size. Those things are congruent. And if they're the same shape but different size, they're no longer congruent, but they are similar. Okay? Corresponding, that's when we have the sides or angles in the same position but in different shapes, and we'll talk more about that in a second. We have regular polygons, that's where all the sides are equal and all the angles are equal. Call that a regular polygon. And the opposite of that would be an irregular polygon. That's when we have a polygon with different side and angle measurements. And last but not least, we have a line of symmetry, and that's going to be a spot in the polygon where we can split the figure into two congruent mirror images. All right, so what are these questions going to look like when we talk about congruency? Well, here it says complete each statement to show that each angle or line segment is congruent. Here we have the angle the triangle ABC. And we know it's saying the triangle because we see this little triangle mark right here. So that's how we name the triangle, triangle ABC. And the first question says angle BCA. Now it's very important that we keep that order in mind. BCA. It has to go in that order, BCA. So now let's see, that's going to look like this. So the triangles are spun around. Notice they are reflected. So we have to figure out what angle would correspond and be congruent with BCA. Well, if we start with the B, what point in the other triangle corresponds with B? Well, it looks to me like it would be D, and then up to F, and then down to E. And it has to be in that order. So angle BCA is congruent to angle DFE. Again, must be in that order. Have to have the letters in that order. Okay, so how about line segment CA? Now, where's CA? Oh, there it is. Okay, it's in blue. And again, we're looking for the corresponding congruent line segment to CA. Has to be in a certain order. So we're starting at the top and moving our way down. Well, that's easier. I believe that's going to be FE, line segment FE. Okay. And last one, line segment ED. Oh, we're starting on the right triangle this time, and we're going from the E to the D. So now if I do that corresponding congruent line segment on the triangle, it's going to go from ED. Let's see. I think it's going to start on the far end, and we're going to have AB. Those are the congruent corresponding parts. Here's where it gets really fun. We have an irregular polygon, but it's okay because the irregular polygon is actually congruent to its partner there. So we have a figure, and I guess technically that would be a pentagon because it's a five-sided polygon. So we're saying figure CMJXT. Wow, that's a lot to name. And they name that by just the letters CMJXT. Okay, that's how they are naming this guy. And then we have PDNER. Those two figures are congruent. We know that because it tells us that in the problem. They are congruent. So since they are congruent, which line segment in PDNER must be congruent to JX? So we got line segment JX. Where's JX? We got to figure out what it's congruent to. Well, there's JX. Now, what makes this tricky is PDNER is congruent, but it's been rotated. So we've got to try to figure out where JX would fall if it were in the other polygon. So let's do some magic here. There's JX. If I kind of plant CMJXT on top of our other one, I've rotated it. Now, if I take that away, look where my line segment is. Looks like J corresponds with N and X corresponds with E. So that means line segment JX must be congruent to line segment NE. All right, guys, the last thing we need to work on is regular and irregular shapes. So this goes along with congruency. Our first one is a triangle. The triangle has 3 sides. It is a polygon. Looks like each side has a single hash mark. That means all 3 sides are congruent. And each angle has a single arc. So that means each angle is congruent. So sides are equal, angles are equal. That's a textbook regular polygon. The next one, we have a star, and the star looks like it has a single hash mark on each side, so those are all congruent. But look at these angles. Look at the angle and the point, and then you're like, well, what other angles are there? Well, look at this. That's a big angle right there. And those are not in any way, shape, or form congruent. So if it has equal sides but not equal angles, sorry guys, it's irregular. The next one's a circle. Well, a circle's not even a polygon. Remember, a polygon has to have at least 3 straight sides that close in an area. This is one big curvy line. Sorry, circle, you're irregular. And last but not least, we have a 5-sided polygon. That's a pentagon. And I can tell by the hash marks, all 5 hash marks are singles. So that means that all the sides are congruent. And each angle within that pentagon is called interior angles, by the way. All those interior angles have a single arc, so they're congruent. So where's that going to go? Let's see. Is it regular, irregular? Where's it going to go? Boom. It's regular. That's all there is to congruency, guys. If you had any difficulty, go back and look at the other 2 videos. Well, this one and the part 1. Just review them, and there will be some activities for you to complete. It should be in your email. And as always, go Dukes!